if I get it nice and inked, and I slap it in half, will it stick to the other side? Ah, look at that. Okay, so I inked this side, and when I folded it in half along the vertex, the point appeared right exactly on the other side on my parabola. Okay, I'll do that again. So if I pick a point here, and I fold it in half along the vertex, look at that. The other point was there. Okay, so with parabolas, we have this thing called a line of symmetry, and it's the line that I'm folding my parabola on. See that little increase where I was indenting? That is, it's not a part of my graph. Okay, so it's not part of our graph, it's just something we can use to reference. This is the line of symmetry. Which means, if I have a point on this side, that is some distance away, there exists a point on the other side that is the exact same distance from this line. Okay, so if this was 3 units that way, this point must therefore also be 3 units on the other direction. Okay, so that's what the line of symmetry is useful for. So, do I have a point I could use the line of symmetry on? Let me go ahead and draw in my imaginary line of symmetry. Okay, so this point here, it already has that matching point right there, so I can't use that. But this point here does not have a matching point. So, I could go ahead and draw in this point here and say, by the line of symmetry, that point exists, LS. Okay, so notice I was able to get that point using option number 1 or using option number 2. They are both valid options for finding your other point. Okay, so we can go ahead and draw in our parabola. The last and final step. And remember to use your arrowheads. Alrighty, and that is it. Those are the 5 steps for graphing a parabola. Okay, and remember there will be a paper homework for that one because the math lab does not use the same style that I would like you guys to learn. Alright, one more class activity. The third. Class activity number 3. So Quadratics Applications. Alright, so let's see. We have one problem for this. On the moon, an object will fall 1/6 of the distance it would fall on Earth in the same time. The distance function for a falling object, should have written this down earlier, falling object on the moon is given by s equals 8/3t squared, where s is feet and t is time. Alright, so we have this word problem here. We're told that when we're on the moon, an object will fall 1/6 of the distance it would fall on Earth, because remember, gravity is different there, in the same amount of time. The distance function for a falling object on the moon is given by this equation, s equals 8/3t squared. And we're told s is in feet and t is time. And I believe that is seconds. Time in seconds. Okay, so real quick, is this a quadratic equation? Yes, because we got that t squared. Alright, so part A, there's 2 parts. How far does an object fall on the moon in 5 seconds? Alright, so we're trying to figure out how far an object falls in 5 seconds. So we're looking for the distance. So we're looking for s. So we want s when, what do we know? We have 5 seconds. So that's my time, t. So when t equals 5. Okay, so we're going to go ahead and use our equation as a function. So we want to know s when t is 5. So what would that be? So 8 over 3, 5 squared is 25. And let's go ahead and plug that into our calculator. 8 to 25, I think it's 100, 200. If you have 8 quarters. 25 times 8, yep, 200. All over 3. Roughly about 6.6, oh sorry, 6.667. So if I wanted to round that out, it doesn't tell me how to round it. But if I wanted to round it to whole feet, we would go with maybe 67 feet. 67 feet. So in 5 seconds, on the moon, the object falls 67 feet. Wow, all right. Okay, part B, the last part. How long does it take an object to fall 100 feet? Okay, so this time, what do we want to know? We want to know how long. Long is in terms of time. So I want to know t. So we want t when we have 100 feet. So when s equals 100. So this time it's a little different. This time we're given s is 100. So plugging it into our equation, we have 100 equals 8 over 3 t squared. Ooh, this is a quadratic. So remember, there are 2 ways to solve quadratics. Square root property or the quadratic formula. Which method would you want to use here? Well, since I don't have the regular t value hanging out, I only have the t squared. I want to use the square root property. So to do that, I want to get my variable by itself, which means I'll multiply both sides by the reciprocal of 8 over 3, which would be 3 over 8. Okay, doing that cancels out the 3's and the 8's, and I'm left with 3 over 8 times 100 over 1 equal to t squared. Okay, now I have my t squared by itself, and I'll go ahead and square root both sides to solve for t. And when I do that, remember we need the plus or minus. So plus or minus, and let's see. So 3 times 100 is 300 all over 8 equals t. And we can simplify that. What is 300 divided by 8? Pull out my calculator. 300 divided by 8. It's going to be about 37.5. And then we take the square root of that. Let me check my calculator. So let's see. What did I have? 37.5. Wait, I want to take the square root of that. So square root of 37.5 is going to be about 6.123. So it didn't tell me how to round, so I'm just going to round to the nearest whole. Why not? Let's say 6. So t is about 6. So what's my answer? It would take about 6 seconds for the object to fall 100 feet. And there we have it. We're done with the application problem for quadratics.